All right, let's talk a little bit about exponential functions and money. Whenever you invest money, it is compounded multiple times a year. And what that means is that interest is applied more than once a year. Sometimes interest is applied monthly, sometimes it's applied quarterly, which means 4 times a year, or sometimes it's applied daily. And whenever we have interest that is compounding or adding on multiple times a year, then we need to be working with this formula. A is equal to P times 1 plus R over N to the NT power. And let me explain what these variables all stand for. This A stands for the resulting amount of money. So how much money you're going to end up with after the interest has been compounded over a period of time. The P stands for the word principal. And whenever we're talking about money, what this word means is the initial amount of money that's invested. The initial amount. The R here, that's going to be your rate. It's going to be in a percent, which we will need to change to a decimal. And then the N is the number of times compounded per year. And this N is the same. Both of those N's are going to be the same number. And then T, as you might expect, is time. So let's look at just a couple examples of how we would use this formula. So let's imagine that I have $10,000 to invest. And I'm sorry, I meant to say $5,000 to invest. Let's say that I have $5,000 to invest. The bank is offering me 7.5% annual rate compounded quarterly. Now when we compound quarterly, that means 4 times a year. Every 3 months, interest is added on to the amount. So I'm just going to plug this information into the formula, and I'm going to invest this money for 10 years. So let's see how much money I would end up with if we did that. The resulting amount of money is going to be equal to the principal, or the initial amount, which is $5,000, times 1 plus the rate. Now remember, whenever you fill in the rate, it's given to us as a percent. We need to change it to a decimal, which means I need to move that decimal 2 places to the left. And so for this problem, it would be 0.075. Divided by the number of times compounded in a year, which in this case is 4. And then we're going to raise that to the 4 times 10 power. And if you put all of that into your calculator, we'll get a resulting amount of $10,511.70. So pretty good return on our $5,000. Let's look at another example where we're using, or where there's a different piece of information that we don't know. Let's say that a bank is offering 9% interest, compounded monthly, and I have my same $5,000 to invest, the same amount of money. And what I'm wondering is, how long would it take with this percentage rate, how long would it take for my money to double? How long to double my money? So let's plug this information into the formula. The resulting amount, if I'm going to double my money, that means that I want the result to be $10,000. I'm still starting with the same $5,000 times 1 plus my rate in this case is 0.09. The number of times compounded, they told us that we were compounded monthly, so we're going to compound 12 times, and I'm going to raise that to the 12 times t power. So in this example, the variable that I'm solving for is t, and it's in an exponent. So I have an exponential function here, and in order to solve for that variable, I'm going to have to use a log. But before I can use the log, I need to get the exponential term by itself. And so this would be our base, and of course this is our power. So I need to get rid of the 5,000. So I'm going to divide by 5,000. And I have 2 is equal to 1 plus 0.09 divided by 12 to the 12t power. So now I'm ready to undo this exponential, or I'm close to ready to undoing the exponential. Remember, to undo an exponential, we need to use a log, but I need to know what base to use. And this expression right here is my base. So I'm going to enter that expression 1 plus 0.09 divided by 12 into my calculator so that I can get a little more convenient number for a base. And if you enter that into the calculator, you get 1.0075. And then we still have that raised to the 12t power. So now I have something that's a little bit easier to deal with. I'm ready to log both sides so that I can undo the exponential. And the base of my log is going to be 1.005. So I'm going to do log base 1.005 of 2 is equal to log base 1.0075 of 1.0075 to the 12t power. And the log base 1.005 of 1.005, those cancel out. And so I'm left with 12t is equal to log base 1.005 of 2. And then my final step to get t by itself is to divide by 12. And if you put that whole expression in your calculator, we're going to end up with 7.730 years. And so that means at 9% interest, it's going to take 7.7 years for my money to double. All right, let's do one final example. In this example, let's say that I need to have $20,000 in, let me put a dollar sign on that. I need to have $20,000 in 5 years. I have a bank that's willing to offer me 9% interest, compounded daily. And my question here is, how much do I need to invest? How much money do I need to invest so that I end up with $20,000 in 5 years? I'm still using the same formula, so I'm going to start out the resulting amount. This is what I know this time. I want my resulting amount to be $20,000. The question is, what's my principal? What is the initial amount that I need to invest? We're going to multiply times 1 plus the rate, which is 0.09. This time we're compounding daily, so that means that my n is going to be 365. And I'm going to raise that to the power of 365 times 5, because I have 5 years to grow whatever amount of money into $20,000. So in this case, we're just solving for p. I need to get p by itself, and so that means I'm going to, p is being multiplied by all of this, so I'm just going to divide by that. I'm going to divide by 1 plus 0.09 divided by 365 to the 365 times 5 power. And I'm going to divide by that on both sides. All right, and this is all going to cancel out. And I can just enter that into my calculator. And I get the result that my initial principal needs to be $12,753.27.